Does reality wait for witnesses? Picture a lone tree toppling in a silent forest. Airwaves burst outward no matter who is around, yet at the quantum scale, we meet a very different rulebook. Possibilities remain smeared out until some interaction forces a single storyline. The gatecrasher that exposed this mismatch was Thomas Young's double-slit experiment. Fire electrons or photons through two pinholes and a ghostly interference pattern appears, betraying wave-like self-superposition. Place a detector to learn which slit each particle takes, and the pattern snaps into bullet-like dots. Merely trying to know erases the waves. Werner Heisenberg sharpened that lesson with his famous G-ray microscope thought experiment. To see an electron clearly, you must pelt it with high-energy light. Those photons kick the particle unpredictably, guaranteeing that fine knowledge of position scrambles any hope of pinning down momentum. The uncertainty principle is not a technological nuisance. It is baked into the fabric of measurement itself. Physicists then cranked up the weirdness. In delayed-choice quantum eraser setups, the decision to keep or erase which path data can be taken after a photon has already hit the screen. Depending on that late choice, an interference pattern materializes or vanishes retroactively, without breaking causality. The experiment shows that what happened is defined by the information actually recorded, not by some hidden nudge imparted at the slits. These episodes hint that nature maintains two ledgers. One listing superposed possibilities, the other hard facts. When a measurement is made, the books close, yet theorists still spar over what that bookkeeping means. In the pragmatic Copenhagen story, any irreversible amplification counts as an observation. Many World says the books never close at all. Every outcome lives on in a branching multiverse. Cubism makes the ledger personal. The wave function is your Bayesian belief, updated when new data arrive. Relational quantum mechanics goes further, declaring that facts exist only relative to the system that records them. But if the microscopic world is so mercurial, why does your coffee mug sit obediently on the desk? Enter decoherence. The mug's trillion-particle entanglement with surrounding air and photons sluices quantum phases into the environment faster than we can blink, leaving robust classical probabilities that masquerade as everyday certainty. Echoes of the observer effect even creep into psychology. The Hawthorne studies of the 1920s found that workers changed productivity simply because they knew they were being watched. Likewise, placebo research reveals that expectation can tweak brain chemistry and pain pathways. Technologists have flipped the principle from bug to feature. Quantum key distribution protocols rely on the fact that any eavesdropper's glance introduces detectable errors, guaranteeing provable secrecy in communication. Yet foundational puzzles persist. Proposed space missions like Macro aim to loft nanocrystals into microgravity interferometers during the late 2020s, seeking the first decisive cracks in standard quantum predictions. So, are you a mere auditor of a pre-written universe or a co-author whose questions steer the plot? Laboratory evidence leaves both doors ajar. What is clear is that each act of observation, whether a photon hitting a screen, a scientist reading a dial, or a patient trusting a sugar pill, threads the observer into the tapestry it beholds. The next time you look up at the night sky, remember, in ways subtle and profound, the cosmos is looking back. If you enjoyed this video, give it a thumbs up and let me know your thoughts in the comments below. Don't forget to hit that subscribe button. Share this with everyone, and I'll see you in the next one.